Okay, welcome to this lecture. We are going to discuss today Newton's backward interpolation formula and its application. Now we have seen on previous term that how we can have the derivation of the Newton's backward interpolation formula. Now this is time that how we can demonstrate the knowledge obtained, theoretical knowledge obtained through the Newton's backward interpolation formula. We have so far seen Newton's forward interpolation formula and Newton's backward interpolation formula. Whenever we talk about the forward, backward in a single go or single term, we say that this is Newton's interpolation. So in case of Newton's interpolation formula, we generally discuss the forward interpolation as well as backward interpolation. But this is a very interesting question as it was raised on previous turn by among you that if we apply the forward interpolation formula, Newton's forward interpolation formula, in place of the backward interpolation formula, then what will happen? Whether we would get the answer correct, whether we get the result or not. So these are some very interesting issues. We will discuss these problems while solving or handling these numerical issues. So as we have seen, there are two applications of the Newton's backward interpolation formula. The first application is the interpolation, and the second application is the extrapolation. In interpolation, we compute the value of the function or estimate the value of the function near end value of the data set, the case of the backward interpolation, and we extrapolate the value of the function by applying the concept of the backward difference interpolation formula whenever whenever the values are near, I mean just a little bit ahead of end values of the function. And therefore, in that very case, here we can apply the values of this interpolation formula and we get it. Now time is over. We are going to lock the meeting because you keep on connecting after the time and you are not punctual. So persons who are not punctual, please, just they are deprived from this lecture. You do not join in time. Therefore, I'm not going to allow you. So let us discuss this very example that how we are going to apply the backward interpolation formula. If we look at this very problem, we have the following data set. In this data set, look at the value of x 1, 2, 3, 4, 5, 6, 7, 8. And the value of the y corresponding to value of the 1 is 2, 9, 28, 65, 126, 217, 3, 4, 4, and 513. Compute the value of f 77.5 by using the suitable formula. By using the suitable formula means Newton's formula. In this very case, what happens that by using this means what kind of formula we need to apply. It is our wisdom to think over the kind of formula, maybe forward or the backward formula. So in this very case, now you look at 7.5. 7 point, where is 7.5? 7.5 is in between 7 and 8. This value is the xn, this value is the x1, this is the x0, x1, x2, x3, x4, x5, x6, x7. So this is the end value xn, this one xn, and this is yn. So this is 7.5, it is nearing the end or in the neighborhood of end. So we apply what? We apply here the Newton's backward formula. And we will not apply the Newton's forward formula. And if you say we are going to discuss this issue also, if we apply it, Newton's forward formula, in place of Newton's backward formula, then what will happen? So we will discuss it also. Look at that, since arguments are equally spaced at the difference 1, and we are interested in the value of function which lies near end of the data, hence we will use here Newton's backward interpolation formula. And therefore we form here this difference table. The first is to form the, for us to be decide the nature of the formula which we are going to apply, and the second we decide, then we form this one, difference table. We form the difference table, and thereafter you look at the difference table. The x is 1, 2, 3, 4, 5, 6, 7. This, you look at difference table. Difference table is this is value of y, 2, 9, 28, 65, 1, 2, 6, 2, 1, 7, 3, 44, and 5, 1. The first backward difference is the 7. 2 is subtracted from 9, so this is 7. 9 is subtracted from 28, this is 19. Similarly, 28 from 65, 37. 65 from 126, 61. 126 from 217, this is 91. 217 from 344, this is 127. 513, 344 from 500 and 169. This is the first difference. Second difference is how we are going to compute. 7 from 19, this is 12, and 19 from 37, this is 18, and this is 37 from 61, this is 24. This is 61 from 91, this is 30. 91 from 1 to 7, that is 36. And 21 to 7 from 169, this is 30. This is the second backward difference. You look at the third backward difference. The 12 from 18 is subtracted to 6 here, 18 from 24, 6 here, 24 from 30, the 6 here, 30 from 36, 6 here, 36 from 32, the 6 here. So, and thereafter the fourth difference is, what is going to be fourth difference is 6 from 6, 6 from 6, 6 from 6, 6 from 6. So this is 0, this is 0, this is 0, this is 0. This is fourth difference. So after fourth difference, if you are interested, you can make it out further. Otherwise, this is enough to know that everything is going to be 0. Either you compute or not. But even then, since we are beginner and therefore we must understand each and every step of the problem. So fifth difference, 0 from 0, 0, 0 from 0, 0, 0 from 0, 0. And the sixth difference is 0 from 0 and 0. and seventh difference is this is 0 from 0 means 0. You look at one point is very interesting. Look at here. How many values of the function is given? How many values of the function is given here? Values of the function is given here. 1, 2, 3, 4, 5, 6, 7, 8. 8 values. So what is the data set is? N plus 1 is 8. So what is the degree of the polynomial which is representing this function? Which is representing this function? What is the degree of the polynomial which is going to represent this function? That degree of the polynomial, if you remember, that degree of the polynomial is, if it is data set is n plus 1, data set is 1 plus n, this is a data set, then degree of the polynomial is n. This is what? This is data set, the values of the data set, values of the data set, the values of the data set. The values of the data set, and this is the degree. This is the degree of the polynomial, ix. This one is degree. So in this way, degree is 7. Degree is 7. So degree seventh difference is constant, and the more than degree of the difference more than the degree is always 0. This was the fundamental theorem we have already discussed. So you just look here and observe this very point. I would like to remind you what is the difference. This is the seventh difference. This is the seventh difference. And what is the degree of the polynomial? Degree of the polynomial is 7. What is the data set? Data set, the number of data set. Data set is 8, and less than 1 is the degree. And the n plus 1 means eighth difference will be 0. So differently this will be 0, because here is the difference you are going to 0. So you cannot subtract anything from this, and therefore here the, if you calculate the difference, this will be 0. And this was the fundamental result of the interpolating polynomial, if you remember. Anyway, so if you just here realize the steps taken in the forward interpolation formula, Newton's forward interpolation formula, and the backward formula, so there is no difference in farming out the difference table. Difference is only what? Difference is only is the point that in the forward interpolation formula, we were just observing and focusing on this diagonal line. This line was important. So this first difference was important for us. This value was important for us. This value was important. This was the x naught, this was the y naught. So everywhere in the formula of the Newton's forward formula, we were taking the x naught and y naught. But here now that is not the case here. That is now case is different. What is the case? Case is the backward, then bottom line. This is the top line. This is the bottom line. So bottom line, this is the y, this is the xn. This is the xn here, and this is the yn here. So xn and yn are just values which we can here use in the formula, and therefore we concentrate on the bottom line. So if we concentrate on the bottom line, then if we concentrate on bottom line, then here this is the first difference, this is the second difference, this is the third difference, this is the fourth difference, so forth and so on. So now this difference is going to be used in this formula, and therefore we are going to discuss how to use these very points x and y and the first difference, the second difference, so forth, so on. Now the next step is, the first step is the decision, how to take the decision whether we are going to apply the Newton's backward interpolation formula or we are going to apply the Newton's forward interpolation formula. So that decision is over. We decided that we are going to apply the Newton's backward formula. Second step was the formation or the construction of the difference table. So we have already constructed the difference table. In the construction of the difference table, there is no any difference. It is similar way of constructing the difference table as we were constructing in the forward interpolation formula. Only the difference is that here we are going to consider the bottom diagonal line as compared to the top diagonal line, which were considered in the forward difference interpolation formula. Now, third step, important step is how to introduce a new variable. So new variable, if you remember, the V was the new variable. Here the V, this V was the new variable. This is the new variable, and therefore here x minus x1, xn, sorry, not x1, xn is the formula, h is the, this is the origin, this is the scale. So corresponding to 7.5, we are going to compute the value. So x is 7.5 and xn is 8.0, and therefore this value comes out this. Now new variable has been computed. Okay, the next value is, what is the formula used? I insist on this, and I insist advising this. This is very, very worth mentioning here, that always you have to write the formula each and every steps here, because here mathematics is not so standard in the calculation. If you do not understand the basic idea, that what is the formula, and directly you are applying, this is not good. The marks will be deducted. You keep in the mind in the numerical analysis. If you are not giving the steps, your marks will be deducted. There is no any justification that how you have applied this formula unless you have shown the formula. So we must write the formula used. So after a long process of derivation, we have obtained this very interesting and used formula of the backward interpolation. So, okay, we put up the value here, 7.5. This value is what? This is yn, and this value is what? This is b, and this is factorial 1. This is the first difference. This is b, I mean, this is a bracket like this. This is a b, this is b plus 1, a factorial 2. This is the second difference. This is the b, this is the b plus 1, this is the b plus 2, this is the third difference, and then this is denominator is factorial 3. And then this is the b plus 1, b plus 2, b plus 3 upon factorial 4 into 0. The fourth difference was 0, and therefore the fifth difference is 0. So puts on all values are 0. So we need not writing, but we are beginners, therefore steps must be given. So this is 5.1. We simplify these values, so ultimately we compute it. This is 424.125. So answer is 424.1. So this is the application of the interpolation by using the Newton's backward formula. Okay, let us have the second questions example. From the data set of the example 1, now compute the phi 8.5, the value of the function according to given data. Okay, what we need here, how, what we apply here, what we apply here, what we apply here, 8.5, 8.5, where it is going to lie, the 8.5. 8.5 is going to lie here, means you just look at this data. 8.5, 8.5 is somehow out of the range, out of the range, but condition is what? Condition is that it must, if it is outside the range but little bit later, little bit ahead, little bit forward from the end values of the data set. So 8.3, this is the end value, and corresponding to 8.5, we have to compute the value of the function. So it is little bit later from the end values of the data set, and therefore for this is the process of in extrapolation, and for this extrapolation we are going to use the Newton's backward interpolation formula. This is the justification of this formula. Okay, you just look at value of the function according to the given data. Previous one, the data is the same, difference table is the same, decision we have taken, everything is here. You just look at here, and now it is 8.5, and this is 8. 7.5, or now this is 8.5, so difference is this, and divided by 6, so minus has become 0.5. Formula used, formula is the same, whatever the formula was earlier. Now, therefore, phi 8.5, now this is changed. This is the y1 as usual, this is the v1 as usual, the first difference as usual, but the bottom line, you keep in the mind, this is the bottom line. This is the v, this is the v plus 1, this is factorial 2, and this is the second difference, this is the v, this is the v1, v plus 1, this is v plus 2, this is the third difference, and this is the factorial 3, and plus 0, 0. So if we compute here, so 513.84.5 plus 15.75, this. So 8.5 is equal to 615.125, and look at your data. Look at your data. Your data is what? Look at data. Data is 513, and the answer is what? 8.5. Answer is what? It is around 600. And what is this function? Somebody can tell this function. This is the y. Y, this function is very interesting function. Y is equal to, which is going to be approximated. Y is equal to x cube, x cube, x cube, x cube, and plus 1. This is non-linear equation plus. This is a function. So 8.5 into 8.5 into 8.5 plus 1, and that value must be near the answer. Okay. Now we have given, and if you look at, this is the answer of this. So this is extrapolation. The first case was the interpolation. This is the extrapolation. The justification and interpretation, and the interpretation lying behind this is that it must be near the end value. It must be out of the range a little bit later from the end values, and then we can have the interpretation of the application of the Newton's backward interpolation formula. Now this is another example. The following data set is given: 0, 4, 8, 12, 16, and y is 1.28, 1.1, 1.2, 1.8, so forth, so on. What we need to compute here? Y for x is equal to 15. Where is 15? 15 is somewhere here. And then x is equal to 17. Where is 17? 17 is outside the range. So here the extrapolation, here the interpolation. This is the homework, home assignment, which I am giving you. The example 4, look at. The following data is given as x is equal to 1, 2, 3 in the very order up to 8. It is 1, 4. This is the function is well known. What is function? Y is equal to x square. So compute the value of the function for x is equal to 7.5. Where is 7.5? 7.5 is here. And x is equal to 8.5. 8.5 is where? 8.5 is here. And this will be the interpolation, this will be the extrapolation, the application and interpretation will be done, will be conducted by applying the Newton's backward interpolation formula. Now I would like to answer this. I would like to answer this question that if we apply the forward formula, then what will happen? I told you this is numerical analysis is absolutely the analysis of the error, absolutely the analysis of the approximation science. And wherever error occurs, what is the aim of analyzing the numerical analysis or problem? We have to minimize the error in our life also. What is the ideal person? Nobody is ideal, nobody is ideal. Who is the ideal, near to ideal? The person who is minimizing his or her error, her mistakes, his mistakes, and learning each and every step. So if we apply the forward interpolation formula in place of the backward interpolation formula, the error will be very high. Error will be very high. And if error is very high, the accuracy will be very low. So our purpose of study of the backward interpolation formula as well as forward interpolation formula is to obtain the high accuracy result. And therefore, in place of the backward, if we apply the forward, result bit will come out. Definitely some result bit will come out, and that result will not be near to the best result. Best result will be given by the backward interpolation formula. And therefore, we cannot apply the forward interpolation formula, maybe Newton's, or some further discussions we are going to hold, or something else. So in place of backward, you cannot apply the forward. In place of forward, you cannot apply the backward. And if we do it, the error will be high and accuracy will be low. So I think today is enough. And now if you have any query or questions, then you can ask your questions here.